So let's continue to discuss the solution to this problem. I forgot to mention one thing. So I said that the sample code are provided here, the solution provided here, but the code I provide are actually C++ code. So if you submit it directly here or try to run the code, you will get a compiler error because they're expecting a C code. So instead, if you want to try this code, you should copy them and then switch to C++ or C++ 14. Replace that with this, and then you can run, and it will show it passes, and then you can submit. So it passes or it's accepted. The reason I put the code under C instead of C++ or C++ 14 is because for some of the problem I want to give you a chance to solve the problem yourself instead of looking at the sample solution when you go in. So I don't really expect anyone will start using C, so I put the code under C. Okay, so now going back to the slides, there are some syntax conventions. So first, the case always matters. So uppercase and lowercase are different. And second, you can use white space, tabs, and new lines. And these are used to separate things that need to be separated. And in any place, if you use one white space, it's equivalent to use multiple of them, or you actually inject new lines into them. They'll be the same for computers. So you choose how to use the white space depending on how you want your code to look to humans, so make them more readable. So for example, under the left column here, everything here are equivalent. So whether there is a white space or no white space before and after this assignment operator is equivalent, because the computer easily knows this assignment operator cannot be part of the variable name. So they know this is one variable name, the ZWXY is one variable name, VW is another. So whether there's white space or not between them doesn't matter. Oh, so another thing I forgot to mention is variable names. They must start with one letter and followed by one or more or zero or more letters, digit, or underscore. So there may be special variables that you can start with underscore, but some of those usage have special meaning. So my recommendation is just always start your variable with a letter. So it can be uppercase or lowercase depending on the situation. In C++, lowercase is sort of more commonly used by programmers. So all these are equivalent. What I want to point out in version 3, this one statement actually goes up 3 lines, separated into 3 lines. And the right side illustrate case always matters. So these are all different. In fact, version, actually other than first version, the other one are all sort of wrong. So you will get compiler error when you have them. Version 2 is wrong because capital I int is not something that's recognized as a type, as a built-in primitive type by the C++ compiler. And version 3 is wrong because it's sort of x and y are 2 separate variables. So if I add a comma here, it actually will be a legitimate code. That basically means we are declaring 2 variables, one called x, one called y, and y is initially assigned as a value from this variable. So this variable should be defined and has a value before this line. But that will be at least legitimate code. But without that comma sign, this is not a legitimate code. And V4 actually, if I have other things after this, is actually legitimate. If this is it, and then I start with another statement after that, then this is wrong. So they want this declaration to be terminated by a semicolon. So yeah, so I think we discussed the comments, two forms of comments, and appending a semicolon to expression turned it into a statement. So this cin thing. Okay, so let's talk about this cin thing. So this is how the basic way, the standard way of doing input in C++ using what's known as Iostream. So cin and this two greater sign symbol, these are declared in the file called Iostream, which we include in the beginning of the code. And cin stands for sort of C standard in. So this is where the program by default read input from sort of the terminal. So if you run the program, you can, then it will wait for you to type something to enter that. And that standard in can be redirected to existing files, which is what happens during the when you submit the program. These two greater than sign together is a special operator, and this is defined in that file. What it does, it says let's read data from the input and then store it to whatever on the right hand side of this sign. Because the right hand side is a variable of integer type, the compiler knows that it should expect an integer number and then parse that number into an integer value and then store it here. So this is also expression. So and this is operator, and by adding a semicolon at the end, this becomes a statement. So statements are the sort of basic building blocks of a program. So program generally consists of multiple statements, and we can also have compound statements. Take this form. Let's use a curly bracket. So there's an open curly bracket and there's a closed curly bracket, and then inside the curly bracket you can have 0 or more statements. And some of them can be compound statements themselves. So let's look at the code. From line 5 to line 15, this is one big compound statement, and this big compound statement is the body of the function main. So when we declare the function, we have a type, function name, and then possibly argument, and then followed by one single big compound statement. Or it doesn't have to be big, but one compound statement, which is the body of the function. When you call that function, you execute everything in that body. Inside this compound statement, we have a declaration statement, we have a this statement, and then we have a sort of a more complicated statement that sort of it's a for loop statement, which I use this macro to sort of to as a shorthand, and then followed by a compound statement. So from line 8 to 13, open curly bracket and curly bracket. So this is a this is another compound statement, consists of more primitive statement. Okay. So now going back to the first two lines of the code, no, rather line 1 and line 3. So note that they all start with this sharp sign. So these are known as preprocessor directives. So essentially the program is sort of first processed by a program called the preprocessors. It essentially, you can view what the preprocessor does, essentially fancy find and replace. So for example, the line 1 sharp include, this tells the preprocessor I want to include content of another file inside here, and here this Iostream is the name of this file that we want to include. So this is a part of the standard library that include the variables and operator definitions for input and output. And later we will see other header, these are known as header files. Later we will see other header files that you can include. So what the preprocessor does is literally take the content of that file and put it in here to replace this line. And line 3, this is known as a macro. So it's defining something. So this is really defining a search and replace pattern. So we're defining a macro repeat, and there's sort of argument here. And what happens is when we see line 8, when the preprocessor sees the repeat n here, because the repeat and repeat matches, it will use here the rest of the line 3, starting with the 4, to replace this repeat. At the same time, it will use n to replace any occurrence of x in this part. So then this is a for loop statement. What it does is essentially repeat the n times, and we will explain how this works in topic 2. So yeah, so this is a preprocessor will read this as a definition of what pattern they should replace with what, and then it will go through the code and then do the replacement. And after that, the code is sent to the compiler, who will compile the code. Okay. Yeah. So inside Iostream, we use 5 things defined there: cin, so the input stream; cout, output stream; end of line, and these are read and write. And we will see inclusion of other files in I think in topic 2. And these are macros. So yeah, so this repeat n in our code will be replaced into something like this. So this is sort of a one compound statement that forms the body of this statement. Okay, so I think we've covered all the concepts that we encountered in the solution code for problem 1. There are actually quite a lot of them. So comments, white space, empty line. So the way C++ uses white space is known as a freeform style. So essentially, where you place your code, how many white space, how you do indentation, those don't really matter. And some other languages are not freeform. So for example, in Python, indentation matters, and in sort of older programming language, Fortran, the precision matters. So the every line, something has to be start on a certain column. But in most programming language, they are freeform. So C, C++, the Java, they are all freeform. And we talk about preprocessor, 2 particular things, include and define. Concept of there's a main function, there's primitive types, int primitive type. Yeah, so there's a return statement at the end of the function main. It tells it's essentially tells I'm done with this function, and the return value is this. Declaration, variable names. Yeah, so the assignment. So assignment is one of the operators. The use operator to form expressions, and input and output. So let me just briefly talk about the line 10 here. So what this does is actually read 3 variables. So it will first read the number and then store that in price, and then read another number, store that in bedroom, and then read another number, store that in footage. So if you look at the input data structure, for every line, the first one is price, the number of bedrooms, and then footage. Okay, so that's it. So that's it for now, and we will return to discuss problem number 2.